Welcome back. So for example 2, it says find the missing side length. Keep answers exact and in simplified radical form. Assume right triangles. So on these examples, we're going to practice applying the Pythagorean theorem and then simplifying our radicals using the skills we have. So here I have example A, says I have a right triangle. Okay, because we're assuming a right triangle. And I know one side length. I don't know the other, so we can call that anything. I'm just going to use A. You could call it B if you prefer. You could call it X if you prefer. That's fine too. And then I also have a hypotenuse of 12. So when we have a right triangle and one missing side length, we can use the Pythagorean theorem to find the exact side length. So what we're going to do is I'm going to write my formula out. So a squared plus b squared, which is 5, equals c squared. Okay. I'm going to use inverse operations and subtract 25 over. So 144 minus 25 is 119. Okay, I'm then going to take the square root because right now we're going to inverse operations to isolate A. And normally we write the plus or minus, right? Okay, but remember, we're talking about the side length. We cannot have a negative side length. So we're going to have A equals the positive square root of 119 units. Okay, so this is square root of 19, not 12. 119 units. Okay, so sometimes a diagram will be given to you. Notice on B, a diagram is not given to you, so that would be my first strategy. So it says A equals 3, C equals 6, so we can always assume that this is my hypotenuse when we define C. So if I was talking about a diagram, I know one side's 3, my other leg is B, and then this is 6. Okay, so I'm going to use the Pythagorean theorem. Again, I have a right triangle, so I have 3 squared plus b squared equals 6 squared. Ooh, those look close together. If you don't want to write a b, you can also write an x. That's fine. So we have 9 plus b squared equals 36. I'm going to use my, inverse operations. This is the step I did not show on the other side or other problem. So b squared equals 27. We take the square root. Remember, we technically have two solutions, right? It's a quadratic. So b equals square root of 27. But remember, we're talking about a side length, so we're only going to choose the positive side. So I have square root of 9, and this is where we're using our skills of how to simplify a radical. So b is going to equal 3 root 3 units. Okay, so if we had a triangle, we know that this side length is our 3 root 3. Okay, so I want you to try C. Set up your diagram because I don't see one, so label it correctly with A, B, and C. Try the Pythagorean theorem, and then we'll go from there. Unpause the video when you're ready to check your solution. Okay, so I set up my diagram. My hypotenuse was C. Again, it does not matter if you switched A and B, you labeled them differently. What matters is they're both the legs. So we square both of them. Now this step and this step, some of you won't show, and that's okay, because you could do that mental math in your head. You could also have typed this line and this line separately into your calculator, and it automatically would have outputted a 3 and 6. That's okay as well. But square root of 9 is plus or minus 3, but again, we're finding the exact length. So we have C equals 3 units. Okay, the following examples are further applications of Pythagorean theorem. So again, I'm going to write the Pythagorean theorem down at the top. A squared plus b squared equals c squared. So a right triangle. So first thing I see, I read right triangle. That tells me I'm going to draw a right triangle. Which way you draw it does not matter. Has a hypotenuse that is 2 feet longer than one leg. So I don't know what one leg is, so I'm just going to call it x. But I know the hypotenuse is 2 feet longer than that. So I'm going to have the expression x plus 2. The other leg is 4 feet. So this is my other. So I'm going to label that 4. Okay? Find the unknown side lengths. So what we're going to do is we're going to set up the Pythagorean theorem. So I'm going to take my 2 legs. So x squared plus 4 squared. It's going to equal my hypotenuse squared. X squared plus 16 equals. Now remember, we need to write this out twice. Properties of exponents. And we're going to FOIL. So this is the fun part. Okay, so when I FOIL on the right side, I get x squared. Okay, now going back to Unit 8, we know that to solve quadratics, we need to get all terms on one side. So I'm first going to combine them. So I get x, or combine my like terms. Okay. Now, I need to use some inverse operations. So the first thing I'm going to do is I'm going to subtract my x squared. Oh, and that works out really nice because now those cancel out. So what I'm really left with is 16 equals 4x plus 4. So now we have a linear equation, right? The quadratic terms canceled. And so now we're asking ourselves, how do we solve this? This is taking us way back to the first unit back in September. And we're going to use inverse operations, right? Our goal is to isolate x. So I'm going to do some work over here. So I'm going to subtract 4, right? 12 equals 4x, so 3 equals x, okay? And then I want to know my unknown side, so let's go back and look at each side. So first side is x, which is 3. The next side is 4, so we don't need to do anything. And the next one is x plus 2, and x plus 2 when I plug 3 in. So I'm going to list my sides. So here's how I'm going to write my final answer. 1, 2, 3. So I have an x, a 4, and an x plus 2, right? And we know x is 3. So one side length is going to be 3, another side length is going to be 4, and the next one's going to be 3 plus 2, which is 5. So these are my side lengths. So this is a lot, okay? I'm just going to talk through this problem one more time. Number 1, when you see the word right triangle, you're going to draw a right triangle. You're going to have enough information to label it. To find unknown side lengths, we're going to use the Pythagorean theorem. Okay, so you're going to set up your Pythagorean theorem. You're probably going to have to do some multiplication, some foiling, and then your goal is to use inverse operations to isolate one side or isolate x. So what I'd like you to do on the next one, for example 4, is set up the diagram and set up the Pythagorean theorem. And then we will discuss how to solve. So once you have the triangle drawn and you have your equation, the first line written out, unpause the video. Okay, so I have my triangle drawn. I have my equation set up. So I have x squared plus 24 squared equals the quantity of 3x plus 4 squared. So here's where the fun begins. So we are going to write this out, x squared. So 24 squared, when I type it in my calculator, is 576. And that's going to equal 3x plus 4 written out twice. So I'm going to do a little work off to the side, actually, just to keep my work clean. And I'm going to FOIL this out. Remember, you can also use the box or distributive method. So I'm going to get... So that's 9x squared plus 24x plus 16. Okay, and that equals x squared plus 576. So now our goal is to move all terms to one side and try to solve it. So I'm going to move the x squared to the right. Okay, so I know it's going to be an 8x squared. I'm going to subtract 576 using inverse operation. So I'm going to get plus 24x minus 76, and now we have equals 0. So this is wonderful because we can now solve a quadratic. So now we're going to use our skills. I will tell you they're going to be nice, pretty rational solutions. So at this point, you can either factor or graph. Okay. to find your solutions. You can use the quadratic formula, but they're going to be rational solutions, so the quadratic formula is just going to be a lot of work. So at this point, I suggest you graph. And when you do graph, you're going to get the zeros of x equals -10 and 7 as our x-intercepts. Now let's think about the context of this problem. We want to know the side lengths. And if I plug -10 in for x, that's not going to work because I can't have a negative side length. Right? Because again, we're talking about a real life situation. Okay? So in this case, we're only going to choose the positive side length, which is 7. And I want to know my unknown side length. So I'm going to go back to my triangle. One is x, one is 24, and one's 3x plus 4. So I know one of them. X, and we said x was 7, so I have a side length of 7. And then this next one of 3x plus 4 is 3 times 7 plus 4, which is 25. So my final answer of my side lengths are 7, 24, 25. So sometimes you're going to get an equation that's linear, like example 3, and you can solve it using inverse operations to isolate x. Sometimes you're going to get a quadratic, like example 4, and you would need to either graph or factor. Again, I highly recommend graphing, finding your x-intercepts, and then making sure you only choose the positive one.